45 million of us will develop Alzheimer's during our lifetime.
When you eat sugar, your brain doesn't like it and it starts to shut down, and it leads to Alzheimer's.
Well, not only can you have a leaky gut, but you can have a leaky brain.
Look, bacteria, not to scare people, bacteria love the brain.
What is driving all this inflammation, right?
In a word, our diets. And we can start there and then work through the whole mechanistic pathway that ultimately leads to people losing their cognitive function. So our diets being higher in simple carbohydrates with reduction in healthy fat, reduction in dietary fiber, paves the way through multiple mechanisms for our blood sugars to rise, our insulin activity to reduce, and ultimately that leads to inflammation.
And they call Alzheimer's now type 3 diabetes.
That's
It's
right.
like diabetes of the brain.
Exactly right. So it puts the ball back in the court of you, the consumer, not you, Mark Hyman, the doctor, but you, the consumer, to do something and do it right now. And that is simply change your diet. Other things are really important. Restorative sleep, aerobic exercise, meditation. We could talk about a lot of things.
Yeah, it's anti-inflammatory to meditate.
You bet. But if we can simply focus on the fact that the global diet is becoming westernized, that is increasing inflammation globally, and we're seeing incredible increased rates of things like Alzheimer's globally, those are important dots to connect and important dots to leverage because we can turn this thing around.
Yeah. It's both the diet and how the diet affects our microbiome.
Exactly right.
Which is influencing our brain all the time through creating inflammatory molecules that get to the brain. And how does your poop get to your brain? That doesn't even make sense. Could you break that down for us?
Sure, break down the poop. And as you've written about, and you coined the term diabesity, the relationship between diabetes, higher blood sugar, obesity, creation of inflammatory chemicals, damaging the brain, heart, etc. We now know that what sets what we call the set point of inflammation in the body is a one cell layer thick that, as you've said in the past, separates the garbage dump. Those are your words. From right?
Sewer. I think I call it a sewer.
From the rest of the body. Chemicals in the gut remain, by and large, dangerous, damaging chemicals. We call them antigens, need to stay there. When they transgress the gut lining, get through the gut lining, they stimulate immune cells to create the very mediators of inflammation, chemicals that we call cytokines, that then initiate these damaging activities for cells throughout the body. The downstream effect of inflammation is a turning on of the production of chemicals called free radicals, damaging chemicals that damage our protein, our fat, and even our DNA, and even our energy producers called mitochondria. So it all starts with diet. Diet nurtures our 100 trillion microbial friends that live in the gut and want me to be healthy.
Yeah.
They want you to be healthy, but we have to feed them right.
Think about like a rainforest. It's got so many inputs of light and water and nutrients, whereas a monocrop cornfield.
What you're getting at is, in a word, is diversity.
Yeah.
And just as we depend upon the diversity of in the Amazon forest, which is being destroyed.
It's an ecosystem in your gut.
You're right. It's an ecosystem in the gut. And it's this relationship between our gut friends in our gut and also on our skin, in the brain, who knew, in the placenta, who knew, this relationship that we have to reconnect to. So in a very real sense, that's one aspect of what our son, Austin Perlmutter, and I are talking about moving forward, and that is disconnection syndrome.
Yeah.
All of the manifestations of disconnection, whether it's disconnecting from the messages of our gut microbiome, disconnecting from our DNA that is doing everything it can to keep us healthy, but that we are sending to it the wrong signals by virtue of the process of epigenetics. In other words, our food choices influence the expression of our DNA. Who knew? The disconnection that we have from the good parts of our brain. We'll talk about that later. The parts of our brain that want us to be empathetic and compassionate and planning for the future. The disconnection that we have from each other as people because we're spending too much time down here looking at a screen as opposed to sharing the life of another individual. The disconnection that we have from our communities, from other countries, and the disconnection that we have from the health and vitality of the planet. And that's where we take this, that the survival of our planet is really predicated on reconnecting at all of these levels.
But in a sense, what you're talking about, David, is the role that your brain plays in allowing you to be connected or causing you to be disconnected. And that the way we care for our brains has a profound impact on our behavior, attitude, connection. That's a very radical idea, that what you eat controls your ability to be present, to be focused, to be connected.
And here's what completes the circle.
Yeah.
What you eat, leveraged by, or looked at through the lens of your microbes, does affect your behavior and your choices. And at the same time, those choices that you make affect the health and vitality of your gut microbes. So what you set up is what we call a vicious cycle, whereby eating the wrong foods changes the microbiome, it changes your brain, and makes you less able moving forward to make the right choices. So you make further bad choices, further damaging your gut bacteria, further changing your brain. And let me say that it's not just moment-to-moment changes in your brain that happens. That you make the wrong decisions. But ultimately, as you continue to make these wrong decisions, you rewire your brain through a process called neuroplasticity. So you compromise your ability to tap into that part of your brain that lets you make good and appropriate decisions. And you connect more aggressively to the part of your brain that is much more impulsive and much more fear-based and much more narcissistic.
So basically, we move from a place of love and connection to a place of fear and reactivity.
That's right. And you mentioned Alberto Villoldo. We wrote a book about this years ago called The Neuroscience of Enlightenment.
Power up your brain.
Power up your brain. And it dealt with what can we do first in terms of our lifestyle choices to enhance this process of neuroplasticity, to enhance the brain's ability to make stronger connections. Okay, once we've got that put to bed, in other words, higher levels of omega-3s, less inflammation, aerobic exercise being very important, then let's do the right things, let's make the best choices, and that will then set the stage for hardwiring the brain to those good parts.
It's pretty amazing how, you've been the pioneer in saying this, but the brain is plastic. It can actually change and reverse some of the insults that happen. So not only is it about prevention, but it's about treatment or slowing down of these conditions like Parkinson's and Alzheimer's. And I had mercury poisoning years ago, and early on I had a brain scan called a SPECT scan, which looks at the blood flow in the brain. And I had all these areas of my brain that had no blood flow, that were dysfunctional. They look like holes.
Not a good thing.
They look like holes, like Swiss cheese in my brain. And as I used functional medicine, as I repaired my brain, as I repaired my body to fix my brain, essentially, my gut, and also the mercury affected my gut in terrible ways, I actually repeated the scan, more than a decade later. And all those holes had filled in. My brain had recovered. Now, it's not something that you learn as a typical neurologist, right?
Well, even, when I was 19, I was doing research on what's called microneurosurgery. We had the operating room just got a microscope. And so neurosurgeons didn't have a roadmap to use the microscope because the anatomy of the brain had never been really teased apart microscopically. So our job was to create this roadmap for doing aneurysm surgery. So as part of what I did my research on, we were exploring how we can bring blood supply from outside the brain into the brain.
Yeah.
So I became really kind of handy at tying small blood vessels together, and I was invited to go teach in Madrid, Spain, at what's called the Centro Ramón y Cajal. And there, this is an institution named after Ramón y Cajal, maybe the father of neurophysiology. And I walked into the lab, and there was a statue of him with his statement saying that the brain is immutable. It never changes. It never regenerates. That's it. And you know as well as I do that we were taught that in medical school.
Yeah.
That the brain will never grow new brain cells. That
your brain cells in college, too bad.
Yeah, if you drank too much or whatever. But we know now that the brain, A, can regenerate itself, and B, can rewire or reroute pathways. Mm-hmm. How does a stroke patient recover? Well, he or she recovers because they bring online different alternative pathways. They reroute the signal ultimately, and that's how they can improve. So we take advantage of that process called neuroplasticity. Mm-hmm. And turn it on by turning on the body's production of a chemical growth factor for the brain called BDNF. But at the same time, we have to capitalize then on the brain wanting to rewire itself by behaving in ways.
You remove the insults and you provide the right inputs.
Changing our behavior. The Dalai Lama said that if you want to be happy, practice compassion. And if you want others to be happy, practice compassion.
Yeah.
So it really, it's you can be happier if you can wire into the happy part of your brain by doing things outwardly that are demonstrate empathy, that demonstrate planning for the future.
Okay, so let's get into some of the details here, because you've written a lot about, for example, Grain Brain. This is a new edition of Grain Brain. Everybody needs to get a copy. It's completely revised and updated. It's pretty awesome, and I think this guy has really nailed it. Now, a lot of people are not too happy with these ideas. You've been attacked on television, you've been attacked in the media, you've been attacked in medical journals, including indirect attacks against me and our colleague Dale Bredesen, who's really pioneered the idea that we could actually stop or reverse Alzheimer's, which you actually were talking about decades ago. What are the things that are challenging? You're talking about changing your diet. So let's talk about the food part, because there's such controversy. Should we eat saturated fat? Should we not? Is sugar really that bad or not? Because the Sugar Association says sugar's fine. So why wouldn't we believe them? Right?
So I would say to your viewers, Google Perlmutter and CBS and watch a recent interview. And as
CBS this morning.
Yeah, but just put CBS and Perlmutter, it'll come up. And as they show the book, Dr. Perlmutter's written a new book about carbohydrates in the brain. But before they cut to me, they said, but we reached out to the sugar industry. And the sugar industry told us that we should eat sugar, decades of research, it's all good, have at it. What would you expect them to say? And why would you ask the sugar industry? And my response was, because, it wasn't that long ago that the tobacco industry was telling us we should be smoking cigarettes. That's a good thing. But the reality is, the question that I was supposed to answer, but I diverted because I wanted to really hit the sugar thing, was, Dr. Perlmutter, what you're saying is that all grains are bad. And I've never said that. Despite the name of the book, I believe that when we look at gluten-containing grains, we should avoid them. As you know, there's plenty of research in terms of what gluten, specifically a subpart of gluten, alpha-gliadin, does in terms of threatening what we talked about earlier, and that is the gut lining.
So is that in everybody or just people who are sensitive to it?
It's difficult to say. I think we know that probably most people have some degree of increased gut permeability or leakiness of the gut when they consume gluten, or specifically gliadin. That said, the non-gluten containing grains meaning seeds of grass, things like rice and corn, can be consumed in a quantity that doesn't present a lot of carbohydrate. So if you're watching your daily consumption of carbohydrate and you want to have a little bit of wild rice, have at it. Or some non-GMO corn, good luck trying to find that. But I think that if you're counting your carbs, as you should be, looking at net carbs, that I don't think that's necessarily the worst idea. Having said that, again...
Because, there's been, just to back up on the carb thing, there's been some recent studies published by Walter Willett and others at Harvard looking at thousands and thousands of people, showing that people who eat very low carbohydrate diets don't do well. They die early, or people eating very, very high carbohydrate. But somewhere in the middle, about 50%, which to you and I seems like a lot of carbohydrate.
Yeah.
Do better. Can you kind of address that? Because it's
I think people should eat tons of carbohydrates.
Yes,
you should be eating carbohydrates. I just did a blog with somebody, and it was said why we need more carbs. David Perlmutter, MD, and people. Yes. I think the hashtag was why that's fantastic. WTF, right?
Yeah.
We need lots of carbs because we need lots of fiber in our diets. By definition,
broccoli is a carb.
You bet. It's a carbohydrate.
Than a bagel, though.
So that's right. And there's something magic when you take, you make a bagel or a croissant. I mean, it's no longer a carbohydrate or simple carbohydrate. It's a croissant or whatever it is.
Yeah.
But you're right. So broccoli, kale, I mean, these are good sources of dietary fiber, which is by definition a carbohydrate, though it's non-digestible.
And polyphenols and antioxidants.
You bet. And fuel for the microbiome, fuel for your gut bacteria. So
I actually, in my book, Ultra Metabolism, I wrote carbohydrates are the single most important food for health and longevity. And what I was referring to was vegetables.
But then people take it out of context. They say, yeah, he's not paleo. He's not keto. So I think that, the biggest faults then with with that type of research is you've got to qualify. And the area that needs great qualification is, I'm often challenged by people saying, well, the China study said that you eat meat, you're going to die. And Dr. Dean Ornish says we need a very, very low-fat diet. And people ask me, what do you think about that? And I would say, I agree with both of them. Why do I agree with both of them? Well, I think by and large, the type of meat that people eat that goes into these studies where they come up with the relationships to colon cancer, for example, you bet those are very, very threatening forms of meat.
But it's actually not even meat. It's actually processed meat, which is bacon.
It's processed meat and
salami.
And there's a sense of alchemy that somehow you can feed a cow or other animal that you're going to eat garbage and it'll magically turn into gold. It'll turn
literally
into
garbage.
Yeah.
They find them Skittles and
you bet
that are expired.
So I think there is a place on the table if you choose to eat meat for grass-fed, organically raised forms of meat of animal product. And similarly, do I think that Dr. Ornish has some merit in his discussion of a low-fat diet? Yes, because the type of fat that is eaten in Western cultures is awful.
Yeah.
It's highly processed omega-6 oils.
Soybean oil, canola oil.
Sunflower that dramatically increase the production of inflammatory chemicals in the body and get back to where you and I started our conversation today. And what's really interesting to think about, we've wondered the mechanism for that over the years. We've said, well, and this is a little technical for your viewers, but they'll love it. The omega-6s produce chemicals called prostaglandins and leukotrienes that can be pro-inflammatory. We kind of glammed onto that for many years.
They're like the hormones of your immune system. They create inflammation.
Right. But now we know with all the interest in what's called the endocannabinoid system, which is what everyone's interested in now because of the availability of CBD and the use of medical marijuana, that the omega-6s help to increase the production of two important cannabinoid chemicals that are produced within the body. We call them endocannabinoids because they're produced in the body, 2-AG and another one called anandamide, which bind to a receptor called the CB1 receptor that absolutely explodes the production of these inflammatory molecules. And interestingly, omega-3s...
So to break that down, what you said was eating vegetable oil activates these receptors that creates inflammation.
Yeah, and this is yet another way to understand the beauty of the omega-3s, because similarly, the omega-3s create cannabinoid-like chemicals in the body that block that activity, and that's another important pathway by which the omega-3s are so good for us. So when people like Dr. Ornish say we should be on a low-fat diet, pretty much based upon the type of fat that people consume in America, I'd say he's right. But you can get even more bang for the buck if you not only cut those oils out and fats out, but add to the equation the omega-3. So we improve this ratio of omega-6s to omega-3s, which is so high now in America, down to a level of 3-to-1 or 2-to-1, whereas typically in most people's diets, it's about 20-to-1 in favor of the omega-6s.
These are new. I mean, we didn't have these oils 1,000 years ago, 100 years ago.
No, you're right.
We've increased our intake of soybean oil, which is now 10% of our calories, 1,000-fold since 1900.
And canola oil that health advocates still talk about, which was developed at the turn of the century as an industrial oil to lubricate machinery.
Yeah. Rapeseed oil, they used to call it.
That's a good thing.
And now it's highly GMO contaminated. Yeah, it's an issue. So you mentioned omega-3s. The other issue people are concerned about is saturated fat. And particularly in the context of Alzheimer's, an ApoE4 gene, which is a gene that may increase your risk of Alzheimer's. Well, it does, depending on how many copies you have and so forth. Is this something we should be worried about? I mean, Bulletproof Coffee and everybody.
Yeah, let's
cover of Time magazine says eat butter. Like, what's the deal here?
Butter is back, and let's take that apart a little bit, unpack that, just for your viewers to be really clear that there are some genes that help increase a person's risk for Alzheimer's, and one of them is this so-called ApoE4 allele. And you can learn about it by having an at-home genetic test that anybody can do, and 20% of Americans will carry the ApoE4 allele.
One copy.
And some carry 2 copies, which is clearly associated with as much as a 12-fold increased risk for developing Alzheimer's disease. The ApoE genes are involved in the production of apolipoproteins, and that's a big term, but it has to do with proteins in the body that carry fat, deliver fat to where those fats might be needed. And there is some indication that the benefits of saturated fat for the brain, we'll talk about that in just a moment, and even the benefits of a ketogenic diet, and we'll talk about that as well. I guess I'm putting a lot of things on the plate here.
Okay, we got it. We got time. We might be a little long here.
We might have to add another memory card. But those things are less beneficial in the ApoE4 carriers, meaning that they're not going to gain as much benefit directly from ketogenic diet or a diet that's higher in saturated fat.
Is there harm?
Doesn't look like there's harm. And that said, I think that there are benefits that everybody gains that I believe, if there is some sense of harm, would offset those potential issues, which are very minimal to begin with. And that is what the benefits are from consuming saturated fat is the types that we recommend: MCT oil, coconut oil, the saturated fat that's found in eggs, for example. The benefits are that we enhance our body's ability to produce these important chemicals that are called ketones. There's this huge interest these days all over the internet and certainly in various venues for lectures, etc., in what is called the ketogenic diet.
Like the number one diet books today.
You bet, and with good reason. Diets. And it's a brand new phenomenon for humans. It's only the type of diet we've been on for a couple million years.
So cyclical, on and off of it.
Right. But we've been in and out of ketosis for a long, long time. So it's got a heck of a track record. And we can talk about that, but basically it's a diet that counters inflammation, that enhances energy production, that activates this BDNF gene pathway to create more of that growth hormone to grow new brain cells, that helps reduce the production of free radicals, that helps get rid of damaged energy producers called mitochondria, that helps us with our ability to rid our bodies of cells, for example, that are damaged. So in multiple arenas, being on a ketogenic diet is really a good thing. So I think that the ability of the coconut oil and the MCT oil to make that happen really is very, very powerful.
And there's data that's showing that those actually help improve outcomes in Alzheimer's patients.
There's actually a data that indicates interventionally that simply using MCT oil improves cognitive function in established Alzheimer's patients. And what did I just say? There's data that shows that a nutritional intervention is effective in turning dementia around. There's also data from Iran that demonstrates that probiotic intervention demonstrates improvement on the mini mental status test, which is a standardized test doctors use in the office to determine how well a person's brain is functioning.
It's impressive. I just reviewed a book by the new head of the Lou Ruo Center at Cleveland Clinic, which is the Alzheimer's research program there. And I was shocked to read he talked about using ketogenic diets in patients with Alzheimer's as a way of treating the problem, which is pretty radical. You've got the head of a major academic medical center saying, yes, we can use food as medicine. We're seeing this trend.
Food as medicine, who knew?
And yet there's this incredible backlash about this. We're going to get into that in a minute. There was an article in the Journal of the American Medical Association called The Rise of Pseudo-Medicine for Dementia and Brain Health. And you and I would be considered in the pseudo-medicine quack category. I think for me, it's a personal badge of honor that I'm on Quack Watch.
Me too. Along with most of our best friends.
But the saturated fat thing, I just want to come back to.
And the founder of Quack Watch commented on this article in JAMA.
Yes,
you need to see that.
I'm sure. I feel like I'm doing a good job when I get more people attacking me from certain categories of like Monsanto and the farm industry. But the saturated fat thing is fascinating because I want people to hear that saturated fat is not necessarily bad, that it is something that can be helpful in many conditions. But that's with one big caution, is to avoid what I call sweet fat. And the reason that saturated fat, I believe, causes, and I want to hear your opinion on this, causes problems in the research, which can correlate saturated fat with disease like heart disease and other problems, is that when those studies were done, they're done in the context of people eating saturated fat in a high starch sugar diet. I call that sweet fat. Think of donuts, French fries, ice cream, cookies. These are high fat, high sugar combos that are
Yes.
deadly. So the caution is if you're going to eat saturated fat, you can't eat a diet high in starch and sugar. Yes, high in carbohydrates, right? Plant foods. I always say 75% of your diet should be plant foods in terms of starch, not in terms of starch, in terms of vegetables. In fact, most of your diet should be plant foods by volume, but they have very little calories, and most of your calories should be fat, but it's not much volume. Can you comment on that?
Yeah, sure. And I would say let's even unpack this further. And it doesn't even have to be in relationship to eating carbohydrates, simple carbohydrates, because the data comes from these studies that look at calculating the amount of saturated fat in somebody's diet based upon the foods that they eat. Then they calculate, well, this person eats, a bunch of beef, they eat a bunch of bacon, et cetera. They get a lot of saturated fat. Well, as we talked about earlier, those are the wrong kinds of foods for many, many reasons. Mm-hmm. So this is a calculated determination of saturated fat. It's not a biochemical demonstration that saturated fat does something in the body. Mm-hmm. It's people who ate a diet higher in saturated fat, which delivers lots of toxins, because these are foods from animals that have been fed, as we said earlier, garbage. That's where those saturated fats, how they're delivered to the human body. Mm-hmm. So it's not a clean type of study.
Right.
It doesn't relate to telling a person to take a tablespoon of organic coconut oil. No relationship whatsoever. Look, 50% of the fat in human breast milk is saturated fat.
Yeah.
Saturated fat.
Wait a minute. So basically, breast milk is almost as much saturated fat as pure butter.
You bet. And why is it there? Because it helps for brain development, helps for immune system development. It helps prime
I thought it was 25%, 50%.
50%. It's of the fat.
The fat.
It helps
but
prime.
25% of the calories in breast milk is from saturated fat.
Yeah,
and we're
who knew?
told to get less than 5% by the American Heart Association. So according to the American Heart Association, we should ban breastfeeding.
I think it needs a label. They need to go around and stamp breasts all around the world saying, this is not heart health.
Fat.
Yeah, avoid this. I mean, it wasn't long ago when we were told not to eat avocados or nuts.
Yes.
Because they had high levels of the dreaded fat. That was about the worst. And we know where that came from now. We know how medical literature in the late 1960s was tainted by industry, by sugar, who influenced what was published in the New England Journal of Medicine, as recently revealed in the Journal of the American Medical Association, and ended up on the front page of the New York Times.
Yeah.
And, doctors bought into that. We bought into what our journals were telling us, and it was patently wrong. Now you bring up a journal article from the Journal of the American Medical Association that is castigating our approaches to dealing with brain health, calling it pseudoscience. We began pseudomedicine. We began our conversation today with a discussion of the publication in the same journal, I'll have you know, in November of this year, wherein it was revealed that the so-called Alzheimer's drugs that this article is a proponent of don't work, but actually make people worse. Which is the pseudomedicine?
Exactly. Well, I think, part of the problem is that, our type of medicine has not had the funding to study these interventions. Nobody's funding dietary interventions because they're expensive, they take a long time. Nobody's looking at these complex systems approaches to treating dementia, which you and I have done for decades. It's not just treating one thing. Like our friend Dale talks about, Bredesen, maybe there's 36 different problems, or 54, or 12. And if you don't deal with all of them, you're not going to get better. And our colleague and mentor, Sid Baker, says if you're standing on a tack, it takes a lot of aspirin to make it feel better. And if you're standing on two, taking one tack out doesn't make you 50% better, right? So if you have mercury poisoning and gluten sensitivity and you just deal with the gluten, the mercury still might be a problem and you don't get better. And I think that's a really important lesson. I think this article is very disturbing to me because it didn't really analyze the data behind it. And there's so much data behind the kinds of things we're doing, whether it's optimizing our diet or exercise or restoring sleep or meditation or using nutritional support, which is, the B vitamins and methylation, or getting rid of mercury or fixing the microbiome or balancing hormones. These are the things that we use in Constellation to help optimize brain function. And what we know is that these things work. I mean, the only study that's ever been shown at a scale to reverse or slow cognitive decline is called the Finger study, which was basically using multiple interventions, diet, exercise, stress reduction, addressing risk factors for the heart, for example, insulin resistance.
And therein lies the criticism. Yes, but therein lies the criticism, because the notion of leveraging multiple inputs into a system and looking for an outcome is absolutely at odds with the current model of how science, as it relates to medicine, is carried out. You mentioned Dr. Bredesen has a new book coming out where he actually reviews case studies of reversing Alzheimer's disease. And I had the opportunity to write the foreword for that book. Yeah. And I talked about how this is unprecedented, that he is not looking at what we call monotherapy to find the golden
single drug for
that can be monetized.
Disease, right.
You know, and yet he's looking at using multiple, but getting a great result. So why would we argue with that? But, you know, it is an inconvenient truth for people who want to believe otherwise, that we need to create single approaches with monotherapy, and that can be the home run billion-dollar product that makes the investors very happy.
Well, it's exciting, Dave. You'd be excited to hear that I'm working with some of the top scientists at Cleveland Clinic talking about how do we study these systems approaches? How do we break the paradigm? How do we actually design a trial where we can test this theory, and instead of calling it pseudomedicine, calling it the future of medicine, which is really what it is.
What are the things that are synaptoblastic? Well, step one, there is an energy gap. This turns out to be one of the most important parts about the Alzheimer's brain. As you know, if you just look at a PET scan, an FDG PET scan, you see that there is a decrease in the utilization of glucose by your temporal lobe and your parietal lobe. That is the hallmark, the signature of Alzheimer's disease, and it's present for about 10 years before a diagnosis. So you have a critical energy gap that you need to change. You need to address that gap. And the best way to do it, of course, is with ketosis. And you can, you know, Stephen Kinane showed years ago, you can ramp those ketones up to 1, 2, 3 millimolar beta-hydroxybutyrate, and you can address that energy gap. That's the first thing. The second thing is, when we used to grow the neurons.
So basically using a ketogenic diet, you can increase the way the brain uses energy and make it basically have more energy by feeding it fat instead of sugar and carbs.
Exactly. And there are two problems there. One is that you've lost the flexibility. You've lost the ability. Everyone's stuck on the glucose side. They're not able to use the ketone side. You have to have the flexibility. And then the second is that they have the insulin resistance, so that even though they're trying to use the glucose, which is what they've used for years and years and years because of the standard American diet, they're now unable to do that because you literally have changes in the ability of insulin to signal. You change your insulin signaling IRS1 molecule from tyrosine phosphorylation, which is active, to serine and threonine phosphorylation, which is inactive. You literally shut it down. And when we used to grow neurons in a dish, you know, in the lab. So
basically what you're saying is that sugar kind of screws up your brain's ability to metabolize energy. Is that what you're saying?
That's exactly right.
Okay, because I don't people know what tyrosine and serine is. But I think that's a basic take-home point, is that when you eat sugar, your brain doesn't like it and it starts to shut down, and it leads to Alzheimer's.
It becomes resistant to it, exactly right. It's resistant to the insulin effects, which are so critical for keeping your neurons alive. So the beautiful thing here is that what we saw in the lab reflected beautifully what you and David Perlmutter and Jeffrey Bland were saying clinically. So that if we hadn't had all the great work you did, we would have been stuck. Say, okay, what's the next step we take now from the lab? But here's this beautiful functional medicine all ready to plug in the underlying science of Alzheimer's disease. So in that sense, very helpful. And as you said, sugar damages your ability to support your synapses. So you've got to address, with ketones, you've got to address the energy, you've got to adjust the insulin sensitivity, you've got to get insulin sensitive instead of insulin resistant, which virtually everybody with Alzheimer's is. And then you have to reduce any inflammation. Your brain responds to inflammation by saying, I am being attacked. There's some organism out there, so I'm going to make this amyloid, which kills these microorganisms. But in so doing, I'm downsizing. So you've got to get rid of that inflammation, not just get rid of the inflammation, resolve it, but you also have to find out what's causing it and address that. So those are the first three things. And then you've got to have the support. You've got to have hormones and trophic factors and nutrients that are critical for rebuilding those synapses. Fortunately, before you actually lose the neurons, you first lose the efficiency of the synapses. The synapses don't work well, but they're still in place, thankfully.
Yeah.
So when we do the right things, these start working well again.
Yeah, it's interesting. I remember reading this article, because what you're talking about is multiple different factors that explain the phenomena we see as dementia, but that it's not one disease, that it's many diseases and many dysfunctions manifesting as a particular set of symptoms that are common among people, but it doesn't tell you why. So everybody you look at who's got cognitive decline or Alzheimer's, you have to be a detective and find out what is their particular issue. Is it more insulin resistance? Is it more of an infection? Is it a mold? Is it a toxin? Is it some other nutritional deficiency or hormonal lack, like too much of something, not enough of something else? And what's really striking is that the inflammation is this common theme in all brain dysfunction, whether it's depression or ADD or autism or Alzheimer's or Parkinson's or whatever, it's inflammation in the brain. And so a lot of your work has really been in understanding what is driving that inflammation, because the amyloid, like you said, is not the problem. It's actually your body's attempt to fix the problem. Yeah, exactly. It's the Band-Aid that the body uses and to deal with the inflammation and the microbial factors, which often can come from gut and other factors. So talk to us about how, we need to rethink this, because I remember reading this article years ago in JAMA, which was called Shifting Thinking About Dementia. And there was a great line in there that says, we combine categorical misclassification with etiologic imprecision. And what that means in English is that we categorize people according to symptoms, not causes. Right. And we are not really good at finding the etiology or the cause, right? So we kind of just like throwing, spaghetti at the wall, trying to see what works. And what you've done with the Bredesen protocol and the End of Alzheimer's program is to really map out systematically the ways in which you can identify those factors that are harming your brain. Right. You call them dementogens. Right. And what are those factors that we need to provide the body to optimize and enhance brain function? Right.
Yeah, exactly. So, what happens in COVID-19 again is cytokines. And so, cytokines are killing people. As you know, the cytokine storm is the problem. Well, part of the inflammatory cascade, part of your innate immune system activation is amyloid. So we have to quit thinking of amyloid as the cause of Alzheimer's. Amyloid is just like cytokine storm, except it's longer. Of course, COVID-19 has compressed all the things that go wrong in Alzheimer's into 2 weeks instead of 20 years. But it's the same idea. As long as you have something that is saying, hey, something's wrong with your brain, you are going to continue to make that amyloid. That's part of the response. So you're absolutely right. You have to determine what these factors are. And there are often biotoxins or organic toxins or metallotoxins. Air pollution, of course, has turned out to be a big one. So all of these critical things, and then various pathogens, and there are several of these chronic pathogens, from Babesia to Bartonella to Borrelia to various mold species to herpes simplex type 1 to HHV6A. These are all chronic pathogens, and typically, as you know, we don't know that we have them. So as you said, this is interesting to me that we used to talk about people dying of fever. In the 1600s, people died of fever all the time. And so now people talk about people dying of Alzheimer's. It's no different than fever. You shouldn't have a period after fever, and fever due to what? And you shouldn't put a period after Alzheimer's. Alzheimer's due to what? That's the critical piece. And so the doctors have always put the period. They say, you have Alzheimer's. But we need to know why for each person. And it's not one thing. It's not like tuberculosis. It's always the tubercle bacillus.
Right.
All these different things. So it is a systems disease. That's the point.
Yeah, it's so true. I think in neurology, there's a famous joke that you see the doctor, and it's basically diagnose and adios. Here's the name for the condition you have, and there's not much we can do about it. Goodbye. Get your life in order. Yeah. And that makes me crazy because, over 25 years of doing this and working with people's brains, I wrote about this 12 years ago. And I've seen more and more since then of how we can really impact these patients. I mean, I saw a patient who had dementia. She had Lewy body dementia, which is sort of combo of Alzheimer's and and Parkinson's. She couldn't walk. She was in a wheelchair. She had real cognitive issues. She was trying to run her business. She couldn't function anymore. And we essentially did this detective work that you're talking about, using the approach that's described in the End of Alzheimer's program in the Bredesen protocol. And we found she had tremendous gut issues, tremendous overgrowth of bacteria and yeast in her gut, massive nutritional deficiencies. She was diabetic, poorly controlled. Her thyroid wasn't working. She was postmenopausal and had all these various issues. And we simply corrected those things that we found. And she came back incredibly, and her energy came back, her cognitive function came back. She was able to be in her business again. She was a relatively famous person, was able to record another album and write songs and write a book, where she'd been totally dysfunctional and non-functional before, and was able to even get up out of her wheelchair and start walking. So it's quite remarkable. And this was even over 80 years old. So no matter where you are in the spectrum, we see these remarkable changes that people just don't think are possible. And when you talk to traditional doctors about it, they kind of dismiss it. But there has been research on this. One of our colleagues, and you published a number of papers looking at these case studies, but one of our colleagues, Richard Isaacson, did an incredible study that looked at similar kind of personalized interventions, not even the full protocol, and saw that he could not only stop, but he could slow it, and he could also reverse some of the symptoms of cognitive decline. So can you talk a little bit more about what kind of approaches you do to looking at the factors that are going on, and maybe sort of list some of the key factors that you're finding that are common among these patients?
Yeah, and I think the best way to do that is to talk about the subtypes. So what we described published back in 2015 is when you start to look at these, to do the very evaluation that you just talked about, then in fact what you find is that there are people, although there are multiple contributors, people tend to have specific subtypes. So type 1, inflammatory. These are people who have exposure. They may have leaky gut. They may have periodontitis. They may have metabolic syndrome. Lots of reasons that they have inflammation, and that's the critical driver. And you can literally follow the molecular pathway from NF-kappa B activation, part of the inflammatory pathway, to where it's producing the amyloid, which, as I mentioned, is part of the inflammatory pathway. So that's the type 1. And those people, you need to look for things like HSCRP, TNF-alpha, things like that. And then you need to use resolvins to improve these. And then you need to identify where this is coming from and attack that. So getting, again, upstream is critical. Then there's type 2, which is atrophic. And these are the people where they have low vitamin D, pregnenolone, progesterone, estradiol, testosterone, on and on. The critical supports for this: nerve growth factor, brain-derived neurotrophic factor, B12, all these things. It takes, as you know, it takes a lot to keep a brain functional. You have over 500 trillion synapses in your head. You've got an amazing supercomputer inside your skull. So you've got to keep that supported and prevent it from downsizing. Again, this is a disease of insufficiency. And by the way, one of the most common things we're seeing now, nocturnal hypoxia. People don't realize it. The doctors don't check it. They say, oh, I don't snore. I don't need to look at this. And it turns out that when you actually look at it, you see that the oxygen has crept down during the night into the 80s, even into the 70s. We see people in the low 70s who don't realize that they have problems with oxygenation.
So sleep apnea, you mean? Sleep apnea.
It's often without sleep. That's the key. Some of the sleep apnea is the tip of the iceberg, but there's upper airway resistance syndrome as another one of these. And there are people who just don't get enough oxygen at night, even though they don't have full-blown sleep apnea. So that's critical to check. And then, of course, we talked about the ketones earlier. Then there's the type 1.5, which is glycotoxic. And this is the people where they've got both inflammatory changes because of glycation of hundreds of proteins. And they've also got the atrophic effect because they now have resistance to the insulin. So that's type 1.5 or glycotoxic. Those are the factors. You got to look at their hemoglobin A1C, their HOMA-IR, stuff like that.
And glycotoxic means sugar being toxic to the brain, and it forms these crusts, sort of like a creme brulee on the top of your brain, so it can't really work properly. And that you talk about atrophic, which means lack of things to help the brain grow. Trophic factors are essentially the fuel or the food or the ingredients that the brain needs to function, including hormones and the right nutrients and vitamins and fish oil, all kinds of stuff that the brain actually needs to function. Yeah. So you talk about the way you identify this, and I thought this was brilliant the first time I heard about it. Everybody knows they should get a colonoscopy to check their colon. but you come up with this term called a cognoscopy, which I love, which is essentially how do you do a deep dive into your brain and all the things that affect your brain that cause risk of cognitive issues. And by the way, all the things that you measure with a cognoscopy are all the things we measure for any chronic illness to look at. And some are more prevalent in different illnesses. But with Alzheimer's, you've really come up with a model of a cognoscopy. So can you talk about what is a cognoscopy? What should we be looking for? How do we get it? Can we get it with our regular doctor? Or is this something that you really need specialized care for?
Yeah, it's a great point. And people have told me don't use that term cognoscopy. It sounds so horrible. But it's simple. It's easy to remember. And we all know we should get a colonoscopy when we turn 50. So we recommend everybody 45 or over get a cognoscopy. And as you said, it is things related to chronic illness. But the key is to prioritize. I mean, that's the key. The people who are getting the best results, as you know, are the ones who are prioritizing the things that are the most important drivers. It's different for each person. For some person, it's going to be getting at that Borrelia. For the other person, it's going to be getting at that mycotoxin. And another person, it's going to be the glycotoxicity. So today it's very simple to get a cognoscopy.
One might be mold, one might be Lyme, one might be sugar, right? One might be mercury, right?
And might be vascular. A common one is people just don't have the vascular support for their brain. And this is why they are downsizing. And so if we return that support, we return the oxygenation and the blood flow, they do better. So the way you can get a cognoscopy, it is three things. It is, number one, a set of blood and urine tests, easy to do. Number two, it is a simple online cognitive assessment. And if you're completely asymptomatic and doing great and you're just in for prevention, you can stop there, just those two things. If you have any symptoms or you're not scoring well on the cognitive tests, you want to include number three, which is an MRI with volumetrics. You want to know the volume of your hippocampus. You want to know the volumes of your frontal lobes and your parietal lobes and things like that.
And hippocampus is that little memory center in the brain, tends to shrink.
Right.
And I've heard you present some cases that when you've done these cognoscopies, you start these interventions that are in the End of Alzheimer's program, your new book, which everybody should get. And you map out the changes over time when you implement the Bredesen protocol. And and remember the story you told of the neurologist, the neuroradiologist who looked at the scans and was like, this is before and this is after. Doesn't make any sense. I've never seen this in my entire life to go from like 20% of what it should be to 70 or 80 or 90% of what it should be. Can you explain how that happens?
Absolutely. And, we see this again and again and again. We're actually just publishing another paper showing not only increase in hippocampal volume, but also improvement in PET scans, where you go from a PET scan that shows Alzheimer's to a PET scan that doesn't show Alzheimer's. We also see improvements in electrophysiology. So improvements in EEG, improvements in evoked responses, and of course, improvements repeatedly in cognitive scoring and testing. So this is happening because you are putting the things in that actually support the brain. You're getting hormones and trophic factors that are critical. So the brain is now making the synapses once again. Now, we don't know yet, is it making more neurons? Is it making just more synapses? Is it changing in terms of its astrogliosis? We don't yet know what's happening at the cellular level, but we do know that that atrophy is improving in many of these people.
So you said two things there that sort of struck me. One is that your brain can grow. You can rebuild brain tissue that's been damaged by the insults and literally grow your memory center, which correlates with improved cognitive function on the brain cognitive testing. And second, you said you can do a brain scan that you can see Alzheimer's on. You can repeat the brain scan and the Alzheimer's markers on the brain scan are gone. Like that. That's like what? Stop presses, headline news. Why isn't this on the cover of New England Journal, JAMA, cover of New York Times, Wall Street Journal? What's going on here?
Yeah, well, partly because, of course, the standard is, do 1,000 people and then do the whole study. So, at the beginning, you have to start somewhere. With just getting the airplane off the ground, you got to start somewhere. So we're looking, as you said, at these various cases. We are in the midst, I should say, of the first trial in history in which we look at all the different contributors for each person and address all these different things. We'll be finished with that in December. So very enthusiastic about that trial. But yes, we do see in these anecdotes that we're now looking at, we see improvements in PET scanning and electrophysiology and hippocampal volume and all these things. When you are getting these people to improve and to do the right things, you're literally just restoring a synaptoblastic neurochemistry. And
what that means is you're creating a brain that likes to build new brain cells.
that is capable. And it's over almost 30 years ago it was discovered. It was, of course, I was taught years and years ago that the brain doesn't make new neurons. You get the ones you have and that's it. And then about 30 years ago, it became clear that, hey, there are neural stem cells and you actually do make new neurons throughout life. And so it's a question of which ones do you keep, and do you have them interact with other neurons? Do they become part of the functional network? So it turns out you do make more of them, and if you do the right things, you can keep them and you can keep their interactions.
Now, one of the big topics that you cover is the microbiome, leaky gut, inflammation, Alzheimer's. And so most neurologists aren't saying, well, let me look at your digestive system. Let me look at your gut and seeing if there's inflammation there. And how does that connect to the brain? And we talked to a colleague of ours, Rudy Tanzi, who's been pioneering some of the work around finding microbes in the brain. We thought the brain was sterile. We thought the brain had a blood-brain barrier that prevented anything bad from getting in. Well, it turns out that barrier is only semi-permeable and that things can get in. And they can be even microbes. So can you talk about this amazing new research on the gut and the brain and the microbiome and how that impacts what we have to do with patients with Alzheimer's? And by the way, that patient that I had who had really had brain dysfunction, her main issue was her gut, and we fixed it up after decades of being constipated, needing enemas to go to the bathroom and laxatives and tons of bad bugs growing in there. It was just amazing what happened. We fixed all of that.
Absolutely. And I think that, when a neurologist makes a diagnosis of Alzheimer's or pre-Alzheimer's, the best thing the neurologist can do is refer the patient to a functional medicine doctor to deal with all the things that are driving this problem. But of course, the neurologists have felt like, oh, this is our province. We have to give the drug and watch you go downhill, which is really unfortunate. I think that's going to change. So absolutely. The gut is a driver. And I think one of the most interesting studies that was done in the last couple of years was a group, they were actually studying rodents, but what they were doing was injecting Candida. And they wanted to see how long does the blood-brain barrier keep the Candida. They injected it into the blood vessels and asked, okay, what happens when it goes by the brain? How long can the brain keep it out? And the answer was it went in immediately. So there is, Candida, and this is in a normal animal. So the fact of the matter is there is much more communication, just as you pointed out, and as Rudy has been pointing out, there is much more communication between the brain and the periphery than anyone thought possible. And what have the pathologists shown us? When they look in the brains of patients with Alzheimer's, what do they see? Herpes simplex in the brain. They see Candida in the brain. They see Borrelia in the brain. They see P. gingivalis from your dentition in the brain.
Gum disease.
All these different gum disease. So the bottom line is our brains are communicating with the periphery much more than anyone thought before. And as you said, we actually probably have a normal brain. As much as that kind of blows my mind, we actually probably do have a normal brain microbiome, and we're going to have probiotics for our brain at some point.
Cognobiotics, right?
Cognobiotics, yeah, there we go.
Wow, that's incredible. Well, the approach also that is needed is something we don't do in traditional medicine, which is how do you restore a healthy microbiome, right? And this is what the focus of functional medicine is. How do you take the symptoms that people have, or even they may not have any symptoms in the gut, but look at the environment in there and optimize it by taking out the bad stuff, putting in the good stuff, and using the functional medicine approach to really heal the gut. So I think what you're saying is that each patient is different, and some may have gut issues, some may have other issues. One of the other issues that really affects people is heavy metals, and there's been a lot of talk in the past about aluminum and Alzheimer's, but it was sort of ignored. And I remember a patient I had, one of the first patients that I was like, I don't know what I'm doing with Alzheimer's. This patient's been diagnosed with Alzheimer's dementia. I have no clue if anything I'm going to do is going to work, but I'm going to try my basic framework of functional medicine to see if we can just take out the bad stuff and put in the good stuff. So I did a cognoscopy of sorts, got rid of the dementogens. And what was really striking about this guy, Dale, was he was 7 years old. He was a CEO of his major family business, couldn't function at all, sort of was in the corner, basically depressed and not functioning. Nobody wanted to be around him. and he had pretty significant dementia. But when I looked at his story, he grew up in Pittsburgh, and he lived in Pittsburgh, and there's a steel plants there. And almost every patient of mine from Pittsburgh is mercury toxic because they put coal ash on the streets, they put it on the fields, gets in the food, it's in the air. And he had a mouthful of fillings. And normally when you do a challenge test for mercury with a patient in functional medicine, you see a level of 20 or 50. That's like, you worry about that. That's high.
Yeah.
100, I've had maybe 20 in my whole life of doing maybe 10 to 20,000 tests. His was 350. I'd never seen anything like that.
Yeah.
I had one other patient, I think I had 400, but almost nobody like that. And I got rid of his fillings. We detoxed him from the mercury. He also had all these genes like ApoE44. He had methylation gene problems that has to do with the vitamins. He had genes that affect insulin resistance. He had years of gut issues. He'd had irritable bowel for decades and was on stelazine for his gut. And so he had all these issues that we treated. So we fixed his insulin and blood sugar. We fixed his gut. We fixed his B vitamins. We got rid of the mercury. And the guy literally came back like Rip Van Winkle from the dead. And it was the most striking thing I'd ever seen in my life. I was like, holy cow. Like I just cured Alzheimer's. And I'm like, and this was like probably 15 years ago. And I'm like, what? And that was really began the process of me going, wait a minute, the brain is so fixable if we understand the insults, which you have mapped out so well in the end of Alzheimer's. And if we understand how to actually repair and heal the system. So talk about mercury and the metals and how these affect the brain, because this is not to say that everybody with Alzheimer's has heavy metals, so they don't. But I've had a number of patients that makes a huge difference when you deal with it.
Yeah, but as you said, a certain number of them, that is the key piece. And here's the thing, I mentioned earlier, your brain makes amyloid when it is under attack by microbes because it's trying to kill the microbes. But interestingly, the gene itself that amyloid comes from, which is called amyloid precursor protein, is a gene that is responsive to metals. So there's literally a metal binding region on the RNA, this piece that's going to be making the protein. So it responds to mercury, it responds to copper, zinc, iron. So this thing is part of what's binding up those metals. So it actually binds up. So what happens is you can actually give mercury. And as you indicated, mercury is literally a cause of Alzheimer's. Not in everybody, but in a small group of people. Probably something like 3 to 5% of all Alzheimer's patients, which still is a lot of them. There are going to be 45 million people with it who are the currently living Americans. 45 million of us will develop Alzheimer's during our lifetimes.
5% is a couple of million of people have metal issues.
Exactly. This is a big problem. So this is why, as you said, you want to check this on everybody, because if that's one of the contributors, you need to deal with it. And when you do, they do better. And it increases the production of the amyloid. And it both, interestingly, it induces the amyloid and it induces the tau as well. So it is a great way. If you want to give yourself Alzheimer's, take some mercury.
Eat some sushi.
Yeah, exactly.
But,
tuna sushi.
But the funny thing is, that not everybody accumulates the mercury, and it's a lot has to do with genetic variation. I personally had mercury toxicity, and I had cognitive dysfunction. I felt like I had dementia. Really, I did. My level wasn't 350; it was 187, which is bad enough.
Still, yeah,
and it's still bad enough. And so I understand from a personal point of view what this does, and it's one of the most potent toxins on the planet, probably second only to plutonium. It is the most potent neurotoxin, and it's unconscionable to me that we don't, as a profession, really think about the role of toxins. We check the blood levels, but that doesn't really reflect the total body burden of these metals. And so there are ways through functional medicine and the approach you're talking about to really do this.
So what is really the root of these things? You were sharing with me before we got on the show that Parkinson's and ALS and MS and Alzheimer's, there's so much in common. They're almost the same disease with different manifestations, like the same tree trunk with lots of different branches.
Right. That's right.
How does that work?
Well, I think that, there's been a lot of research recently, really quite frankly, from IFM, which kind of led into
the Institute for Functional Medicine.
Right.
Yeah.
Right. That basically talking about, the role of the microbiome in chronic disease. So I'd be honest with you, I was very skeptical of that whole thing until I saw my first patient with ALS who told me that he had SIBO.
Yes.
Okay. And I'm like, okay.
What is that?
Right. I was like, what is SIBO? Like,
You're a neurologist. Anything that happens south of the neck, you're like, what's, I don't know.
Right. So I said to him, I go, look, SIBO there, ALS here. He goes, no, my ALS is being caused by my SIBO.
And what is SIBO?
Well, he didn't know. I didn't know at the time what SIBO was. Okay. I got to get to the punchline. So what is SIBO? Good question. So what is SIBO? But I sort of started thinking like a microbiologist instead of a neurologist, meaning that my patient's telling me he has an infectious disease that's associated with his ALS. Since he's one person, instead of trying to divide and conquer that he has, SIBO and has ALS, what if SIBO and ALS were somehow related? That was the first question I started with when addressing this particular patient.
Most people don't know what SIBO is. So what is it?
What is SIBO? It's small intestinal bacterial overgrowth.
So it means bacteria are growing in your small intestine.
Oh, you asked me that question. You want me to answer that question?
Yeah, because
sorry.
people who knows what SIBO is, right? sounds like a new kind of.
I thought everyone knows what SIBO is.
Isn't that the convenience stores in airports, SIBO or something?
right.
No. Right. SIBO means that you've got bacteria growing in your small intestine, where it's not supposed to be. It's supposed to be in the large intestine, and when you eat food, it ferments quickly and you feel bloated, distended. You get what we call a food baby, and it can cause a whole host of other problems. It's been linked to fibromyalgia, to depression, to heart disease. I mean, pretty much everything, right? So now
I'm thinking about, can a bacteria be the cause of ALS? Now, this is at this point, a completely unfounded theory that, people have told me to this day. I'm still crazy for thinking this. Okay. So anyway,
I don't think so.
Good. So my second patient with ALS had ulcerative colitis and ALS.
Oh.
And I said, oh, this is interesting. So I started looking at ulcerative colitis, and I was like, wow, ulcerative colitis looks like it's immune mediated. Not that it's autoimmune, but immune mediated from bacteria.
Yep.
So I started looking at all this gastroenterology literature about ulcerative colitis and Crohn's. And I'm going, oh my God, it's the same bacteria.
Yep.
So
I got ulcerative colitis from C. diff.
Right. Exactly.
Almost died from it. And it made my brain not work.
Wow. It's just amazing that you're sharing that with me because, I'm a neurologist. I don't think about ulcerative colitis. I don't think about Crohn's. I don't think about fecal transplants. I don't think any of that, right? All of a sudden I'm like, okay, I'm thrown into this thing where if I believe that C. diff is the cause of ALS, I got to kill this disease, man. I'm like a disease hunter. Like I'm going to nail this disease, right? So what happens?
You're like the Indiana Jones of medicine.
I'm the Indiana Jones of medicine, right? You're screwing my patient. I'm going to get you first. My best friend is like a former FBI agent. So it's like, that's like when they follow serial killers, that's what they do, right? They get all the evidence and then they kill them. Or they arrest him at least, right?
First they hopefully arrest him, then they try him,
but
and
in
then
C.
they kill
diff,
him.
you got to kill, not arrest. But that's a whole separate conversation. But anyway, so I started putting together how C. diff neuropathologically can produce motor neuron disease, because I had to sort of establish what those pathways were in order to convince my colleagues that they should look into this.
So right? kind of connect the dots between stuff that goes wrong south of the border there in the gut
to the nervous system
and what happens to your brain.
Correct.
But they're actually connected, right? There's a whole thing called the second brain, which is your gut.
Yes.
And your brain, which is your brain.
Right.
And they're all connected through all kinds of hard wiring.
It's one body.
Right.
We're one body. Isn't that holistic medicine?
Yeah,
the idea that you treat the patient.
That's why I joke. I always say I'm a holistic doctor because I take care of people with a whole list of problems. And they're all connected.
They're all connected. Why? Because you have all those problems, right?
Yeah. I mean, there's this horrible phrase in medicine. It's called comorbidity.
Right.
Which means you have multiple chronic diseases
that aren't related.
Like, you have heart failure and diabetes and hypertension, and you have kidney failure, and you have, this and that, and Alzheimer's. They're not related. They just happen to be showing up in the same person at the same time. Oh, it's a coincidence.
Right.
Nonsense.
Right.
They're all connected.
Right. Just like it was a coincidence. I was walking down the street and I saw an old doctor who actually, his son was a patient of mine. Like, oh, that's not a coincidence. Like, there has to be something of value for that. But yes, it's not a coincidence that these diseases occur in one person because they're interrelated to each other. So I started asking that question. How are these separate conditions?
What's the mechanism?
What's the mechanism, right? So here's the mechanism. The mechanism is protein aggregation.
That's a fancy word. What does that mean?
Protein aggregation means that chronic disease, by definition, whether it's neurological or cardiovascular even, or even cancer, these are where proteins are malformed. The proteins,
so funny looking proteins.
The proteins have weird
get
shapes.
damaged.
They're
or injured or produced in ways that are funky.
Right, and that's the common factor in every neurodegenerative disease, meaning that they're misfolded proteins. So
Amyloid and Alzheimer's.
Amyloid, tau, alpha-synuclein, all of the different proteins that are associated with their pathology for those diseases. They're all protein misfolding disorders. I said, okay, well, why are they misfolding? Like, what's stopping them from folding properly? And what controls...
because it's not only the amino acid structure of a protein that matters. It's the three-dimensional structure of the protein and how that interacts with receptors and how it interacts with other proteins and how it interacts with your cell membranes.
Everything. It's a three-dimensional world.
Right.
It's not two-dimensional. So I started thinking, okay, what is causing the proteins to misfold? Okay, and I think this is well known. It's not something I discovered, so this is actually well known that misfolded proteins are caused by microtubule dysfunction. And microtubule dysfunction is caused by other things. There's actually lots of things that cause microtubule dysfunction, but guess what bacteria produces primary microtubule dysfunction as its pathology?
C. diff.
100%.
But many other bacteria might do that too?
I looked for that question, and I could not find as strong an evidence of a direct A to Z link between Clostridium. Clostridium actually makes a toxin that you can actually test for called Rho kinase. So Rho kinase, I said, what does Rho kinase do? Well, how is Rho kinase producing the lethality? The lethality, is that the right way?
That's good enough.
Yeah, lethality.
Deadliness.
Deadliness, right, of cells. And it does it by poisoning microtubule-associated proteins.
What's a microtubule?
Microtubule is like the architecture of this house. Think about all of the scaffolds and all of the walls. Everything makes this house.
It's all the framing.
It's the framing of the cell, but more. It's not just the framing of the cell. It's in charge of all of the export-import. The border control.
So it's the trading company.
Right, and reproduction. I mean, how cool is it has that function, right?
Yeah.
It's all about reproduction for microtubules as well. So it has interface not just with ALS, but also cancer. So if you look at the cancer data, these are protein aggregation disorders as well. Different proteins, obviously, right? But possibly the same mechanism of what's causing those misfolded proteins. So I was like, okay, I'm not ready yet for this. I mean, like even this conversation, but I've not begun to look at evidence of C. diff in cancer yet, because right now I have to focus just on neurodegenerative diseases.
Yeah.
But in that case, so we're at the potential, issue that, how do we prove this, basically?
So then what causes, besides C. diff, though, there's other things, right, that cause it, right? Inflammation and...
Well, inflammation as a result of infection.
You're saying there's one cause, which is C. diff for all neurodegenerative diseases?
In order to prove that hypothesis, two things have to happen going forward. Two things. The first is we have to establish that there's C. diff in the brains of patients with Alzheimer's disease. Mm-hmm. Guess what? That study's been done.
Yeah.
It also showed that there was some...
poop for brains.
Poop for brains. Is that a true website or something? Or I thought Rudy made that up. Poops for brains.
Well, there's another way to say it, but
more importantly, clinically, I mean, look, people can say, oh, it's an epiphenomena, right? Like the brain is, already decomposing, and of course you can have the bacteria emerging when the person's dead. Fair argument, right? Maybe it's not that Clostridium is causing the disease, but it's there for the ride as it eats your brain up after you're dead. Right, that's sort of the
meaning they find out an autopsy, but
right.
Maybe
it doesn't mean that it was there when they were living.
Yeah,
right. So fair enough. That what that means is that we have to demonstrate.
So they ran for the hills as soon as the person died. Is that it?
I guess. I don't know. It's true. Probably unlikely, right?
Yeah, unlikely.
Exactly.
Yeah.
But in fairness to that sort of counter punch, what the medical community would ask for going forward is, especially clinically, like we can make a decision that we think that this is definitely C. difficile in a patient with a disease like Alzheimer's, right? To make that conclusion clinically, you have to have absolute 100% evidence that bacteria is actually causing that disease. With some, obviously not every disease is going to test positive, and not only is the challenge here that the majority of patients who test for C. difficile who have dementia, Parkinson's, Alzheimer's, and what have you, have negative tests for C. diff.
In their stool.
In their stools, right. And so people that are sort of looking at this picture with me, if you will, are saying exactly that. Well, it can't be C. diff because we're testing C. diff in the stool and it's not there. I say, well, guess what? It went uptown. Okay, it used to live downtown, but it likes uptown more. Why? Because A, we give them PPIs, which they love that alkalinic environment.
Acid blockers.
Like
Pepsid.
And what do we give them that they love most of all? Antibiotics. C. diff loves antibiotics.
It's actually an antibiotic-associated infection.
Exactly.
That's how I got it.
It is,
I took an antibiotic for my bad tooth, and I ended up getting C. diff.
Yep. If that's not a word of warning to all the listeners, I don't know what is. Yes, exactly right. It's called antibiotic-associated C. diff. So I started asking patients with neurodegenerative diseases if they had a prodrome when they first started getting sick, and all across the board.
I mean, like symptoms that happened before they got.
Of course. Well, you ask questions like that. Right? I want to know like what they did as a baby, basically. You know, even though they're 70 years old. Why you ask? I don't know if I asked my mom that question, but, but younger patients, you can ask them that question because they're with their parents. And I say to them, I ask them 3 questions. I go, did you have a lot of antibiotic exposure before you got sick? 100%. It's like I know the answer before I even ask the question. It's just a question of how many antibiotics they had and what course of antibiotics they had. And the second question that's worthwhile to ask clinically is, do you have trouble actually mounting a fever? So that's a question that I was surprised by the answer that most my patients basically have said, no, you know what? I've noticed I really never get a fever. I'm like, oh, okay. So,
which is not necessarily a good thing.
That's right. It's not a good thing at all, because the only thing that actually will treat spores, right, is heat. If you look at
that's why we get a fever, right?
That's why we get a fever.
You get a fever because it's your body's mechanism for killing infections.
It's I make a joke with people. I say to them all the time. I said, name one disease that humans have cured. Like, they always mention infectious diseases because that is the truth. We've cured infectious disease. But the only thing that actually cures disease is our endogenous mechanisms. Fever and sleep basically are the 2 endogenous mechanisms of holistic medicine.
And
right?
endogenous means stuff that you do yourself. Your body does it.
Your body's doing it for you.
Yeah.
But you have to help the body do that. You can't be staying up late and taking PPIs to watch, Seinfeld episodes.
You can't have your pizza followed by your Prilosec and stay up all night watching Game of Thrones.
Correct. Now in perfect disclosure,
that sounds fun.
I've done all of those, except I actually do eat the pizza when I'm watching those shows, and I got to work on myself basically. Okay, doctor, treat yourself.
Yeah.
Right. But anyway, yes.
So this whole conversation is fascinating to me because, from a functional medicine perspective, many roads lead to Rome. In other words, just because you know the name of the diagnosis of the disease you have doesn't mean you know what's wrong with you.
Exactly.
And the truth is there can be 10 or 20 causes for the same disease.
Right.
And I think that's probably true even of neurodegenerative diseases 100%. Like Alzheimer's. So I just want to make sure that we're not saying that every single person with Alzheimer's has C. diff.
Right.
Or that's the cause, because it could be something else.
Exactly.
It could be Lyme disease, or
100%.
It could be heavy metals.
But the point is,
resistance.
But I think the sort of like the devil's in the details, if you will, right? Meaning that yes, I think there's very strong, compelling evidence at this point that bacteria are the cause of neurodegenerative diseases. Not my research.
We talked about Rudy Tanzi, who's a Harvard scientist, one of the discoverers of some of the presenilin genes, which are the genes that show that people are at risk for early Alzheimer's. He actually said they were discovering all these microbes in the brain, which we thought was sterile, and that we had this blood-brain barrier that protects us.
Right.
And you're saying, and he's saying that barrier is not always 100%. And that stuff can leak through. Not only can you have a leaky gut, but you can have a leaky brain.
Look, bacteria, not to scare people, bacteria love the brain. Why? 25% of the body's glucose is used by the brain. They know where to eat. They're going to, Le Pen, or that fancy restaurant is downtown. Like everyone else is eating downtown. They're getting, our brains.
Can bacteria live on ketones?
100%. But not. Wait, that's very important. They prefer simple sugars. Why? Because they're lazy, right? They want instant gratification. So they like sugar better than ketones.
But ketones and ketonic diets work for some of these neurodegenerative diseases like Alzheimer's and even LS and brain cancer.
That's right. That's right. And I think one of the mechanisms, to be honest with you, is that ketones actually improve mitochondrial function, but they're not a good substrate for bacteria. They're a great substrate for us. Bacteria don't like them because they like eating fast food, basically.
Yeah. So feed them sugar, we eat fat.
That's right.
Okay, so this is just a breakthrough idea, and this isn't just an idea. You've actually treated patients using this approach and seen some really extraordinary things.
Yes.
So can you share with us, a little bit about this case you were sharing with me earlier about ALS, which is a horrible condition. Stephen Hawking had it. It was called Lou Gehrig's disease after the baseball player. Essentially, it's where your nervous system is affected by the killing of the neurons in your spinal cord, which makes you basically paralyzed. You got fasciculation, which is twitching. You eventually can't move your arms and legs. You're in a wheelchair. You can't breathe. You need a respirator.
You wouldn't wish it on your worst enemy. You would not work.
It's like a slowly getting paralyzed. Right?
Yep, that's right.
And never has there been a treatment that has stopped or reversed it.
Right.
And you're saying that you've seen patients where this has actually happened.
So, we are in the process of validating that data. Yes.
So, yes, we need more studies. Yes, we need to do research on multiple patients. Right. But even if there's one patient where you've seen a change, it raises the question.
By the way, it's made me go crazy, by the way, because, I'm finally glad to be a neurologist. Being a neurologist is like being a nihilist or a masochist.
Diagnose and adios, right?
Well, it's worse than that. It's like diagnose and let me not tell the patient that they have ALS. Let me treat them for, like a CIDP picture, because they don't want to actually make that diagnosis for people. It's the hardest diagnosis you could make for a patient, because everyone knows ALS is incurable disease, right? Mm-hmm. I mean, it's 100%. It's like not even pancreatic cancer is better. Well, you have a 5% chance of living with pancreatic cancer. You have 0 chance of living through this disease. 0.
So based on your hypothesis that it's infectious,
yes,
that plays a big role, if not is the main role.
Right.
I personally shared on this podcast that I went to a place in Mexico called Santa Viva, where I and my wife both went through this treatment called hyperthermia, which essentially is where they heat you up to 107 degrees, which sounds crazy and is scary.
Right.
But actually, we did both fine, and it killed a lot of infections that we had.
Yeah, you mentioned it's amazing.
Lyme.
Right.
My wife, her viral loads of very tough to treat infection called CMV came plummeting down.
Yep.
She felt much better. I felt much better. And and so this is a therapy that is not much used in the United States, but is used widely in Europe, is used in Mexico and other countries as a therapy for some of these types of infectious diseases and even cancer.
Right.
So how does the theory work behind this with something like ALS?
Well, the idea is that, fever is the way of actually denaturing spores. So
okay, that's a big sentence. Can you unpack that?
Sure. So human cells have their proteins that either fold properly or not fold properly at a certain temperature, right? Bacteria have their own temperature zone, like their ideal climate, and spores have another ideal climate, right? Meaning that to kill a spore
is like a baby bacteria.
A spore is a baby bacteria. And that's what I believe personally is the reason that patients have amyloid accumulation, that the spores are creating this protective cover against antibiotics that actually is, in fact, the amyloid being produced.
So the amyloid is like the armor for the bacteria.
Yes, they're like the bomb shelter.
Yeah.
It's the biofilm is the bomb shelter for these little baby bacteria. Yep.
And so how does hyperthermia work to disrupt that? And what is that procedure?
So it works, hyperthermia works by, it's a very narrow window of temperature. Meaning if you give too much temperature, you can actually hurt normal cells as much as bacterial cells. If you don't give enough temperature, you've done nothing.
So it's like Goldilocks.
It's
right?
like Goldilocks.
You got to get it just right.
You have to get it exactly right. Okay. And that's part of the way that the hyperthermia technology has been developed is by really understanding that the brain itself can provide feedback on the tolerability for human cells, because brain cells are going to tell the brain, hey, this is pretty hot in here.
You don't want to fry your brain.
Right. Can you turn the thermostat off now? So the part of the device actually is to get the brain temperature back into the feedback system where it's self-regulating, so that you never reach a point where the temperature is harmful to your own cells.
And so, they often, in places where they do this, they'll give, at the peak of the temperature, they'll give antibiotics or antivirals.
Right.
Does that make sense?
To give antivirals?
Or, to give antimicrobial treatment to patients when they're at the peak of the fever, because the idea is that it sort of flushes out the...
For acute infection, yes. I would argue
like
that...
Lyme or...
Well, if the Lyme is acute, certainly. I mean, I don't think that I think you got to be weary of the issue that by, robbing Peter to pay Paul, for instance. Let's say that C. diff is, let's for argument's sake say this is a polymicrobial disease, okay? As opposed to
like lots of different bugs.
Lots of different bugs, as opposed to just one ringleader that everyone else is following, okay? So Lombard believes it's that C. diff is the ringleader, okay? And all these other guys, Lyme, HSV, they're tagging a ride because it's such a great killer that it's like, okay, great, we'll take the leftovers, no problem here. We'll take the leftovers. So my concern is clinically that if we start treating patients, with bacterial drugs like Rocephin, whatever it is for chronic Lyme, yes, you're addressing chronic Lyme.
I mean, the C. diff gets worse.
Yes, exactly.
Yeah,
exactly.
So the heat alone is enough to disrupt the C. diff?
We haven't demonstrated that yet, to be quite frank, but what's been demonstrated is that by applying hyperthermia, that we're able to actually see improvement in clinical symptoms of patients with ALS.
So people's muscle strength, this is a progressive disease, so it gets worse and worse and worse. Every visit, they're worse.
Right.
You're seeing patients that it stops or gets better, which never happened.
Correct.
Right. So this is a major breakthrough.
I think so.
Major breakthrough. And this is not something new. This has been around for a long time. And so where in the world is most of the research being done on hyperthermia?
For ALS?
Period. I mean,
most of the research on hyperthermia actually is cancer research. So they call it chemohypothermia. So people can look up a lot of data on how hypothermia affects cancer. But as far as I know, there's zero data until now applying hyperthermia for ALS. We will be the first people to actually talk about applying hyperthermia for treatment of ALS.
And what about things like Alzheimer's or Parkinson's or MS?
Well, the difference in those diseases are that in Alzheimer's, right, it's very difficult to induce hyperthermia in a patient with Alzheimer's disease. Why? Because you need to be compliant. The treatment itself is, it's fairly rigorous, as you know from your
They put me to sleep.
They put you to sleep, right? We don't want to put them to sleep, though, right? Because we're concerned about protecting their brain. So, if you have a patient who's got, end-stage Alzheimer's disease, for instance, I don't see how this is going to be helpful for them. But early, 100%. Early. In fact, I will talk later, not about the case now, because we're really just in the beginnings of this case. But yeah, I think it would be applicable for Alzheimer's disease as well.
Have you seen any patients reported or in the literature
definitely not.
Or anywhere?
No.
But it's a theory.
Yes, still a theory.
And MS? What about MS?
MS, there's data on actually the opposite, right? Which is how do you induce hypothermia, right? Because in MS, it's it's an inflammatory disease, obviously, right? Which, by the way, I also believe is caused by Clostridium, but not C. diff, where it's especially important to actually identify at that stage that this is bacterial. So I don't know what they're...
So what is the idea with MS? That you wouldn't want to use hyperthermia, that you wouldn't want to use heat because it makes it worse?
Well, because remember, when you heat up a patient with MS, what happens? They usually get worse. So the trick is...
But maybe not enough, right? Maybe it's not enough.
That's right. Maybe you haven't reached the threshold to actually, use the body's fever mechanisms against
Because there's
bacteria.
links to MS and Epstein-Barr virus and other infections. There's links to Alzheimer's and herpes virus infections.
Right. So yes, the whole principle is applicable for all those diseases, but we don't know yet if it is applicable yet until we clinically demonstrate that, right? Yeah, I think that this is going to be a treatment that's going to be very important for a lot of different diseases, Mark.
So there's this whole theory that the body has a mechanism for dealing with this, and it has these own proteins that are produced in response to heat. And there are things we learned about in medical school. They're called heat shock proteins.
And I learned something very important about heat shock proteins from Dr. Lessler, because remember that, people looking at how to induce hypothermia, right? So there's all sorts of research. There's actually even a drug in clinic for ALS that is the mechanism of action is based upon increasing heat shock protein through a pharmaceutical agent. So I was at this lecture, and I thought I knew everything basically, and I learned that actually you can induce.
Because you thought MD stood for medical deity, is that it?
Medical deity. Yes, exactly.
We all got that training.
Yeah.
The truth is, we know close to nothing.
That's why I said at the beginning of this talk. Thanks for inviting me, but I really know nothing. Just disclaimer. But anyway, so yes, actually in MS, the goal is to induce heat shock protein through hypothermia. Hypothermia.
So you get people cold.
Not people, the brain.
The brain.
Right. How do we do that?
Chill the brain.
Chill the brain.
How do you do that?
Yeah.
Ice blocks around the head?
No. No. Well, I'll invite you up, and you could see for yourself what that looks like.
All right. Dunk your head in ice water?
Nope. None of the above.
Okay. So we have to be in mystery here?
A mystery about what the device looks like, you mean?
Yeah.
It's basically the same concept as building a hyperthermia device, except remember now that technology itself was developed basically for anesthesiologists. So this was developed at Yale by Dr. Abreu, who's the person who actually discovered a way of measuring brain temperature objectively, externally. Okay, so that's kind of where this whole thing started from, to be honest with you. And
you don't have to stick an electrode in your brain. You can literally map it out from the outside.
You can map it out from the outside. So the ability to do that now allows a clinician to not only heat the body to create hyperthermic states, but through other types of modalities to actually cool the brain safely externally with in the same way, meaning that you can actually apply a small device to a region of the skin, periorbital location, and you can actually change the temperature of the brain through this what's called the brain thermal tunnel.
And that also creates heat shock
protein 70.
Not cold shock proteins.
And I didn't know that until I was in Australia.
That's amazing. So you're hopeful about the future of neurology, it sounds like.
It's the first time I've been hopeful about anything in my life, to be honest with you.
Hey YouTube, if you like this video, you're going to love the next one. Click on it to check it out today.
Because you don't need a doctor's prescription for health. What you need to do is to make that part of your life in a natural way.
Well, if we can get food reimbursed by healthcare, it's a game changer. And actually, I'm working on that at Cleveland Clinic with the food pharmacy, which is the idea of actually paying for